So good afternoon. We will start our afternoon session with an industry expert, and we are privileged to have with us Mr. Abhijit Devgurikar, who is founder and CEO of Copper Cloud IIOT. He is going to talk about applications of sensor technology in Industry 4 and IIoT. So before I hand it over to him, I will talk about him. I will give a brief introduction. Abhijit is founder and CEO of Copper Cloud IIoT Private Limited, a company that builds Industry 4 and Internet of Things solution. Under Abhijit's stewardship, Copper Cloud has been designing and delivering end-to-end automation, digitization solution for MSME manufacturing companies since 2018. Before founding Copper Cloud, Abhijit has worked in various technology roles at the banking giant HSBC for over 15 years. He has performed various roles in technology delivery and architecture in different geographies. Abhijit is a certified Scrum Master, certified professional in project costing and scheduling, a certified solar entrepreneur. His contributions to academia are also worth mentioning. He is a member of Board of Studies and Academic Excellence Council of esteemed institutes at Pune and has served as Professor of Practice at multiple institutes. He has the honor of being nominated by AICTE as Distinguished Expert for peer review of their FTPs. So I welcome Abhijit, and we are very thankful that Abhijit has accepted to be a guest faculty for this trial course. Abhijit.
Thank you so much, ma'am, for the warm words of welcome, and thanks everybody for being here today. So you can call me Abhijit. So as ma'am said, I'm coming for the first career, so to speak. I have a pure play IT background. The last 6 years, we have been getting ourselves up to speed on electronics, microelectronics, sensor technology. And then we have built on top of that, added more layers of technology to the stack. So now, as Copper Cloud, we call ourselves not as an IoT company, we call ourselves an Industry 4 provider. All right. Primarily, we'll get out of what we do as our day jobs. Primarily, we are in the business of converting traditional shop floors, manufacturing companies, to smart shop floors, which means we make their machines smart. We make their processes smart, we digitize processes which are not digitized. Most of the stuff happening in the Asian manufacturing industry is pen and paper right now. The processes are digitized, but the actual execution of those processes is pen and paper. We are trying our hardest to get all of them into digitization, and wherever possible into the sphere of automation, which is where we start getting into sensors and electronics and IoT. IoT is at the heart of what we do, and one great thing about IoT is that it's not one technology, it's a gateway into dozens of technologies. So when I hire people, I tell them first 2 years I will write designation what you have, uske aage you write your own designation. If you want to do more of network, call yourself a network engineer. If you want to call yourself a cloud engineer, call yourself an electronics engineer, right? So the beauty about something like IoT, it's a bridging technology, so you can get into lots of things by opening that one door, right? So that's the little bit on the introduction. Where's my, caller mic is working now? Am I audible to the end? All right, great. So I generally like to start sessions with a bit of visuals, all right? So this is probably the only animated slide I have. Let's make it interactive, right? Anybody has seen this GIF before? Can somebody just volunteer what this is about? What is this map? Waterways. It looks like that. It's not that. But thanks for speaking up first. So now that sir has opened up the doors, other people can have enough courage to speak up. Make a guess. I will not cut any marks this once. This is the map of the major undersea internet cables of the world. So we have this assumption that internet flows through satellites. 90% of internet flows through undersea cables. Now, why I want to start with this is, I don't come from microelectronics world, I come from the world which is at the edge of microelectronics, right? And I'll tell why that is important. This map looked very different in 1990, right? Maybe many of us weren't around in 1990. I want to open one part of it. All right. So this is where we are, correct? In 1990, Indian economy was undergoing a very tough time. Our gold was, mortgaged to World Bank, and we were at the verge of becoming what today Venezuela has become a few years ago, correct? And we literally didn't have many options. But at that time, another company, big company worldwide, was going bankrupt, and that company owned some bits of this infrastructure, right? So in 1990, P.V. Narasimha Rao's government took a gamble and said, "वैसे भी we are not left with much, right? This company is literally selling it for pennies." And when a big company goes bankrupt, there are not many sellers, because you don't just buy the company, you also buy the debt and the liabilities that come with the company. So Indian government bought out this global company which owned part of the network, all right? And that part is this part, right from here all the way till here. So on paper and practically as well, Indian nation owns the part of the internet that flows through this part of the ocean, right? If you want to see like a NASA control station, you can go to the new VSNL control center on Arandi Road. They have a complete building dedicated to this, so where people monitor how this piece is being performed and how it's to be defended, etc. All right, and that's when our IT industry really launched off the ground. So we had IT industry from 85 onwards and all, Infosys and all, TCS, but suddenly lots of IT companies cropped up, correct? Patni came up, Infosys became a big name, TCS started taking up global projects. That happened because we had free internet. We were not paying anybody for internet. When Jio introduced internet, it was almost free, right? Because Jio owned the internet cables or satellites. So Indian company, our tax money owned this part of the internet. It became virtually free for us, and lots of internet companies, software companies came up around between 1990 and 1998, correct? And that's when we say if you are today a software giant in global terms, a lot of that label owes itself to what happened in 1990, right? There's always a 10-year lag before we see the momentum of anything, correct? So big gamble, but it paid off big, okay? Why I'm telling you this story is something very similar is happening in the world of microelectronics now. So fortunately, we are not desperate for anything, but the geopolitics is changing, right? People don't want to depend only on one or two countries for their electronics. Indian government is very hell-bent, very bullish on not just remaining software, but going into hardware as well. And just like in 1990, what government said is, "Tumhare paas paisa nahi hai na, I'll set up software technology parks for you, STPs, where you can start up your software companies." Similar thing is happening now. The government is saying, "I will set up VLSI parks for you. I'll set up hardware equipment for you. You want a VLSI, forging machine, I'll pay half of it." All of that is happening, correct? Because we want VLSI startups to be as successful as software startups were in the last 20 years, correct? And this is where it becomes relevant to the topic of this thing. When we are talking about multiferroic materials, electromagnetic materials, it's a very big world, lot of good research happening there, but a big part of that contributes towards new microcontrollers technology, new sensor and actuator technology, transducer technology. And it is not just hardware, it is not just software. All that contributes to is a very nice word here. I love that the topic has this word called smart world, because this is the foundational technology, one of the foundational technologies which gets added with other foundational technologies, and what we get as an ultimate outcome is smart spaces. It could be a smart vehicle, it could be a smart city, it could be a smart auditorium, smart trains, smart factories, smart homes, correct? So this is where I come in, all right? So to be honest, I really am not very knowledgeable in the first two bits of it, correct? And when I was undergoing management training HSBC 15 years ago, we were told one thing: if you've been asked to talk about a goat and you don't know about the goat, tie the goat to a tree and talk about the tree, correct? Fortunately for me, this is the tree, all right, because this is my world. All right, so I build smart spaces, I build smart stadiums, we are building smart factories. If you are anybody wearing a Fitbit or health fitness band, most of the time if you buy a watch today, it would be a fitness band watch, correct? That's part of my world because that's an IoT device on your wrist, correct? So let me speak about what you are researching, what you are building. You are building new things, you are building technology that doesn't exist, right? You are doing pure research. In some cases, you are doing applied research. The technology exists, but you are finding better ways to deploy that technology. All that, how it is being consumed in the world of industry, I'm here to talk about that. All right. I'm happy to make this interactive session. If you want to stop me in the middle, I'm happy to do that as well. Where did I keep the phone? All right. We have about hour and a half, hour and 40 minutes. Okay, so we have time. So there are two parts to this session. The first part is I want to walk you through the applications of the research that's happening and what we've been talking about for the last 4 days. And the second bit is at the end of this lecture, so to speak, I will walk you through a kind of a case study where I'll show you how people are actually using this when they're using a smart factory. But I also have one more exercise in the second part of today's schedule. I want to do one more case study with you in a participative manner, where I'll tell you the problem statement and we'll try and solve that problem together. I picked one of the more challenging use cases that was thrown at us. One good part of IoT is that everybody's challenge is unique. So if you like solving unique challenges in the real world, right, not just behind the screen of a computer, IoT lets you look at those challenges. So I'll share one such challenge with you and we'll try and come up with maybe one or two solutions on how that thing can be solved. All right, that will be the practical part of this session. All right. Okay. So this is largely what the major theme of this workshop is: materials and semiconductors research. One channel goes towards sensors, actuators, related stuff, which is non-computing infrastructure, right, which is physics, right? You convert electrical signals to physical signals or physical quantities to electrical signals. And the second one is equally important, which is the microcomputing platform, right, where we get into the not really transistors, but the Moore's law thing. How can you cram more and more computing power in the same area of silicon, right? You get both of these together and then you can do some very nice things. You can build IoT systems, right? So embedded programming, you can run programs on it. The moment you have sensors and a RAM and a bunch of silicon where you can run programs, you can tell it what to do. You can tell it, okay, if the temperature in the room exceeds 30 degrees, then switch on the fan. That's kind of what IoT does, right? IoT edge AI. So nowadays IoT is not just IoT. AI is a big word, it's a very big bucket, right, big black box. We just say AI, but there are like 20 types of AI happening inside. One of the types is called edge AI or AI on the edge. So the word edge is very important here, and when I have a very quick architecture slide for you where we'll talk about edge, right? Anybody has come across this word, edge computing, so far? New word for everybody? Right. So people have heard about cloud, correct? So when you access your Gmail in the morning, that mail is coming to you from the cloud, right? When you access banking servers, कि मेरा balance कितना है, मुझे money transfer करना है, you do a UPI transaction, that transaction is being executed maybe on the cloud, maybe on the server room of the bank, correct? But when you go for a walk in the morning and then you see कि आपके 10,000 steps में से कितने हो गए, that is not happening on cloud. That's not even happening in the server room. That's happening on the edge. What edge means, it's the literal edge, literal boundary of computing, right? Because beyond the watch is your hand, which is not computing. So the very edge of technology tier, very edge of computing is called the edge, right? So your mobile phone is an edge. Nowadays your car is a computer, right? So if you see on the bottom right hand side of your steering wheel, you see something like a USB port. That's called a OBD port, onboard diagnostics. So even without going to a garage, आप उसमें से आपके गाड़ी की 6 महीने की history निकाल सकते हो. So your car is a computer on wheels now. It's the edge. Now we have been seeing what Tesla cars can do, self-driving cars. Now Tesla car sees a stop sign. It doesn't ask the cloud रुकूं कि ना रुकूं, because that has a latency of half a second or something. In half a second you could well be beyond the stop sign, right? So it needs to take a decision on platform, on board. That is AI on the edge. So whatever happens on the edge is edge computing, edge AI, etc., etc. IoT is all about the edge, right? When you ask Alexa, Alexa, what's the time? To be honest, Alexa doesn't know the time. Alexa asks AWS server, kitne baje hain? AWS tells Alexa, it converts it. Alexa is majorly an NLP platform, natural language platform. It converts text to a speech of any chosen language, right? But it doesn't know what time it is. Now, when you tell Alexa, Alexa, switch on the light in my room, Alexa doesn't grow hands and legs, walks over to the wall and switches on the switch. Alexa sends a command to an IoT device sitting behind your tube light. So, Alexa in that sense is not edge. The little device which is sitting behind your tube light, which actually does the on and off function, that is edge. All right? Okay, so IoT and edge AI. Now you take this, you add IT to it, you add data science, you add all kinds of AI, you add visualizations, you add whatever other technology, Bitcoin is not a technology, blockchain is technology, right? You add all this and then we say we are into the world of Industry 4.0. For the outside world, for people who are not related to technology, they may not hear any of these words. They may not know sensor, they may not know IoT, they may not know edge. The language, the first language word they understand is Industry 4, right? But for people here who deal in technology, all this we know up till the root of the word, it doesn't start at Industry 4. At first, there is this. Application of the first block is the second block. Application of the second block added to more technology is the third block, and applications of the third block become Industry 4. And once you have Industry 4, then you get many applications. For example, smart cities, smart, what have I written? Manufacturing, smart governance, correct? I'll show you a few examples in the next few slides, correct? So, jahan pe bhi word smart aa gaya, typically there's an implicit assumption that there's a little bit of IoT there. AI is not a prerequisite of something becoming smart, correct? Let me give you a quick example. Let's start with a traditional traffic light, right? What does it do? It says 90 seconds to everybody, right? Whether or not there is traffic on the road, it will say 90 seconds stop, 90 seconds go. It's a waste of bandwidth. If you think of road as bandwidth, right? Traffic bandwidth, it's a waste of bandwidth, correct? Now replace it with a smart traffic light. I'm not saying IoT or AI or anything, it's a smart light. What a smart light would do is it will have sensors, maybe IR sensors or some other sensors, which will detect the traffic density in each direction. So, सुबह uptown से downtown ज़्यादा traffic है, it will give more time to the downtown traffic than uptown traffic. दोपहर को people coming back from schools, it will give more time to that street. शाम को downtown से traffic suburban areas में आता है, it will give you more time there. So now the traffic light is smart. It's not just blindly giving 90 seconds to everybody. It figures out who needs more time. It's a smart traffic light. It is still not Industry 4 because this traffic light doesn't talk to anybody else. Now it will be even better if this traffic light can tell the 4 traffic lights adjoining चौराहे पे कि मेरे यहाँ traffic pattern has changed and the same pattern will reach you in under 3 minutes. So you should also change your pattern, correct? Then it has become an IoT or an Industry 4, right? Then we are talking smart cities and everything because we don't just have smart things. We have smart things talking to other smart things and getting something useful done, right? An interesting project many BTech and MTech students bring to me is smart helmet. That you know, if somebody falls, the helmet will send out some information to the nearest ambulance room or whatever else. So we can save lives faster, correct? But then I give this suggestion that don't stop there. Where is the data? You saved one life, fine. But what if when your helmet falls, right, put a GPS chip in there, also detect the lat-long coordinates where this fall happened, and over 3 months, over 6 months, you can build a heat map of what the accident hotspots of the city are. Nothing happens in a uniform way. There's always an 80-20. There'll always be 10 to 20% of roads where 80% of accidents happen. Now you are not saving one life. Now you have the scope to save millions of lives. Because you can, using that data, you can give it to governance. Governance can maybe say, यहाँ one way बनाओ, यहाँ flyover बनाओ, यहाँ पे traffic light लगाओ, यहाँ speed breaker लगाओ. So the more technology you apply, see, the hardware technology is still the same. You still have a smart traffic light, but you have added 2 new things. You have given it the ability to communicate. And once it communicates, then you have taken it to the cloud, right? The moment the data leaves the edge, let's start using this term now, right? The moment the data leaves the edge, you don't have to remain on the edge. All the nice computing, AI, analysis, heat mapping you can do in the cloud. Cloud is nothing but a computer that you can't see. It's not your computer. The computer belongs to somebody else where you are running your program. Think of it as an Uber cab. You're not buying a car. You're buying a ride. Right? So you're not buying the computer. You're buying the computing time. And you're paying only for the time that you use. Okay? So instead of running all your analytics on the edge, which is more expensive, you are running, and see, one is expensive. Secondly, jahan hardware aa gaya, there's a shelf life. Every hardware will die sooner or later. Software doesn't die. Hardware will die, you'll take the software, put it on a new box, it will keep running. Correct? Software can be replicated very fast with a very little incremental cost. Hardware, so I just brought an IoT device to show you. It's a very simple sensor. In the case study, I'll show you. We are using this device. It's a very simple device. All the IoT, the chip, the Wi-Fi, the edge stuff happens inside. There's one sensor here, which is a proximity sensor. It could be 2 sensors, 3 sensors, 4 sensors, whatever. And there's a power supply at the other end. Right? The moment this device sends its data every minute somewhere else, this device ka kaam ho gaya. This can continue to send the next minute and the next minute and the next minute. I'm going to keep this here. You can take a look when you like. All right? But once the data arrives at the cloud, there the stuff comes in the smart domain, where you can apply algorithms, you can apply analysis, you can apply AI, you can apply data science, you can create the whole visualization, heat map, figure out these are the 4 roads that need to be better to reduce 50% of accidents. That's a smart city thing. Okay? So no matter what kind of smart, if you say smart in front of it, we are having IoT, we may or may not have AI, but you're having some combination of hardware sciences and software sciences and data sciences. Data is usually there. Without data, you can't really do much. All right? Fine here? Okay so far? All right. So as I said, this is, I'm assuming this is the stuff people in the room are working very actively on, right, on an everyday basis. This stuff you might be doing as an adjunct, you might be using it, but large part of this workshop is focused on this yellow box, correct? This is the goat, and rest of it is my tree. All right? So let's talk about the tree here. Okay? Where is my? All right. This is going to be the lens of this session. Right? From what perspective I want you to look at it. I want to share a perspective a little bit about what is the impact of either the pure research or applied research that is happening in universities to the man on the street. And in my case, man on the street is people who are using the smart infrastructure. It could be me as a person who's wearing a smart watch. It could be Indian Railways, because now you can check. पहले होता था ना कि बोगी किस प्लेटफॉर्म पे कहाँ खड़ा है, हम दौड़ के देखते थे. Now you can see it on an app. If you go to Pune, is a little behind in some places. If you go to Indore में BTech and MTech students are working with the city administration. You are from Indore? Ah, very nice. Bhopal is also picking up good there. But Indore is very good at this. So students are building this smart bus infrastructure. So I can scan a QR code on a bus stop and I know when the next bus is coming, right? So that's the man on the street, the person who's using the applied research and applying it to solve a real world problem. All right? I want to give you a very quick overview. Let me figure out where is the pointer. Yeah, a very quick overview of what this Industry 4 thing is about. All right? I say IoT / Industry 4, that's not technically true. IoT is at the heart of Industry 4, but IoT plus 8 different things is what actually goes into Industry 4. All right? Sorry. And I want to do 1 or 2 case studies depending on how much time we have. One case study is pure play, a very, very typical smart factory deployment. And I have taken just one. I have 30 use cases. If I go through all 30, you might be here till midnight, so we won't do that. I'll take one use case and I'll walk you through that. And I want, after that, in the practical part of this session, I will give you another use case and we'll try and solve it together. All right? So this is the lens of what we're going to do. Okay? Just one slide on IoT. I guess the name is familiar. Who all have are familiar with the term IoT so far? Just put your hand up. Ever come across? अच्छे से, boldly. 1, 2, 3, 4, 5, 6. Okay, about 1/3 of the batch. Internet of Things, correct? I just want to clarify one thing. When we say thing, ये thing क्या है? This is not a sensor. It's not a device. Okay, IoT is all about the real world. So, a Tesla car having 5 or 6 different devices and a dozen sensors, the sensor is not the thing, the car is a thing. All right, the thing is a very real world object. Let us say I want to know how many times the door opens, and I put a little bump switch here. The bump switch is connected to a small microcontroller. Every time I open the door, the microcontroller goes ping, door opened, right? The door is a thing. The controller is not a thing. So, thing is a very real world entity. All right. So, a network of connected objects, right, which we call things, which are able to collect and exchange information, right, but not just with humans. Our mobile exchanges information with humans, correct, but these devices are connected objects which collect and exchange information not just with humans but also with each other, right. That makes it an IoT network, IoT technology, Internet of Things, correct. I gave you an example of traffic light, so we can, this is called a V2X use case, vehicle to everything. Vehicles talking to vehicles, vehicles talking to traffic lights, vehicle talking to zebra crossings. And when I say talking, zebra crossing doesn't need to be smart. The camera on the vehicle will say there's a zebra crossing here, so I need to slow down, or there's a cyclist on the road. Vehicle talking to the nearest ambulance station there, etc., etc. V2X use case. All right, and this is not very far in most, I would say, European and some cities of US. This has been done. India mein, this has started with a very, very humble beginning where you have this fast, what do you call it, fast tags, right? Now fast tags are mandatory. You can't go on a highway without a fast tag, aapko double toll lagta hai, right? So the whole idea is you shouldn't have to stop at the toll will detect you coming from 30 to 40 feet away, it will deduct money from your Paytm wallet, and by the time you are at the gate goes up and you are through. And immediately SMS aa jata hai, this is the money that has been deducted, this much money is balance, and you can be on your way, right. That is one use case, maybe in Bangalore, or now Amravati is coming up as a smart city from the ground up. So it's far easier to build a city as a smart city from the foundations rather than, you know, retrofitting a city like Pune, जहाँ पे already narrow streets हैं, already roads पुराने हैं, कहाँ खोद के we dig something to put a electric line and पता चले वहाँ पानी का pipe already है. So it's very hard to do it for existing infrastructure. It's relatively much simpler to do it in a जिसको हम greenfield projects कहते हैं. So that's why if you are going to work on some of this stuff, it's easy to get funding. You go to Amravati, there are so many incubators to give you funding for such projects, right? And what is this Industry 4 then, all of a sudden, correct? IoT, we are okay, we find what is IoT. What is this Industry 4? I don't think I have a slide there, but fine, I'll talk through it. What was Industry Revolution? So you guys were out of school much later than I was out of school. So you remember what was Industrial Revolution, right? You have a hand up there? Anybody wants to tell me Industrial Revolution, what triggered it? No? Steam engine. James Watt. Correct? So us waqt watt, if you tell somebody that watt is the unit of power, nobody will buy it. They would say horsepower. Because people are far more familiar with how to use horses, right? So that's where you started industrializing. Before that, everything was a cottage industry. Anybody wants to tell me which was the biggest and most lucrative cottage industry at the time? Everybody wanted to do that job. Not agriculture. Agriculture you had to do. By default, everybody was an agriculturist. But there was another profession before the Industrial Revolution which people really wanted to be in. It was blacksmithy. Because everybody used metal. Who used to make metal? You want to make tools, you want to make shovels, you want to make, you know, implements for agriculture, you want to make swords for the king, everything would be made by blacksmiths, right? So very lucrative profession. Then came the steam engine, and suddenly 100 people ka job one machine would do. The machine is size of this room, correct? Industry 1.0, right? Somewhere about 1850s, 1860s, right? 100 years passed, you had electricity, correct? And with the steam engine, you started proper manufacturing. So you came out of cottage industry and you made industry and you had manufacturing, right? 100 years later, with electricity, you had assembly lines because now you had motors and generators and everything. So you had bulk manufacturing, correct? The iconic example of bulk manufacturing is Model T Ford, the very first automobile that was built on an assembly line. So before that, Ford would make like one car in 30 days. With the Model T car, they started building 30 cars in one day, right? So the Model 3 Tesla is kind of a nod to the Model T Ford, because the Model T Ford was the beginning of Industry 2.0 and Model 3 Tesla is the beginning of Industry 4.0 for automotive manufacturing, right? 100 more years pass, you had computers and you started using computers for record keeping, for computations, for payroll, attendance, reports, everything. Computers are not still doing the job, but you can offset some of your mental effort to computers. Industry 3.0, which happened roughly around 1970s or so, right? And now we are employing computers to even do our jobs in the form of robots, in the form of self-driving cars, in the form of drones. Indian government has already granted licenses to 5 or 6 online stores to start deliveries using drones, up to 5 kilogram payload or something. So you may not be familiar, but up to 5 kilogram payload, you don't need a drone pilot's license. You can buy one, and as long as it's not a restricted military or airport space, you can fly your own drones up to 5 kilogram payload, right? So now when you want to talk to a ticket booking agent, you can log into the system at 2 o'clock in the morning and you talk to a bot. That's a symptom of Industry 4, right? You order something from Amazon, it doesn't go to a person. Look at a YouTube video of Amazon warehouse, right? It's all robotic process. There are things called self-navigating vehicles which do the thing, packing, they prepare the whole package and put it for the van to come and pick up. And the van is your interface. In a year or so, for small packages, you will not even get the van. You will put a QR code on your balcony or somewhere and a drone will come and drop it off. I am not telling you what might happen, I am telling you what will happen positively, right? Food parcels, very good, under 5 kilograms, right? So this is what Industry 4 is, that computers, robots, everything will start doing bits and pieces of our work. People will do design, people will do other things, but the routine, repeatable things will largely be outsourced to. I say computers, but computers is not necessarily something with a screen and keyboard, right? So this is what Industry 4 is about. Industry 3, we are living in an Industry 3 world right now, because we log in, we order stuff, we talk to people on the phone. Industry 3 is largely an HMI world, human-machine interface, because we interface with machines. Industry 4 is largely going to be an M to M world, which is machine to machine. Machines will interface with machines. We will be there for decision making and overriding and changing the rules, but rather than HMI, we'll have more of M to M happening. So in many places, Industry 4 के साथ आपको ये term भी देखने मिलेगी, M to M, M to M, machine to machine interfacing. All right? Okay. And of course, unlimited applications of this, right? You have smart cities, where cities, buildings will monitor their own temperatures, they will monitor their carbon footprints. There's a certification called LEED, L-E-E-D, LEED 2 or LEED 3, which gives scores to how well a building regulates itself, right? We are doing some of this because we are working with warehouses where there are up to 4,000 to 5,000 air conditioning uses in one building. And you can't really sit at a computer and control temperatures of 4,000 air conditioners, right? So we have this thing that in bunches of 20, the conditioners will talk to each other and manage each other, right? So that's already something that we are building in Hyderabad and Chennai, all right? We are talking about smart vehicle. Then smart vehicle is not enough. You need to build a lot of other things to get to a smart city, right? Smart agriculture. Smart agriculture is a little late in taking off, but the awareness is there because we are already getting interest from mango farmers in Konkan belt or kaju farmers in Goa, that how do we automate our things, right? So the awareness is there, just a matter of time. So right now the economics is not working out very well, but the moment that problem is solved, you will see a very big boost in agricultural smart solutions, all right? Smart construction. So now you have sensors embedded in bridges, right? Or pehle hota tha, every 10 years you will do knock testing on vehicles, ki what is the soundness of the vehicle. Or after a tsunami, after an earthquake, you will check ki how sane, how sound the bridge is. Now you have sensors. Hilti is one of the leading companies. Hilti kits aate hain itne, right? So Hilti sensors you put in there, and every 10 seconds it will tell you how sound the bridge is. You don't need to wait for an earthquake or a sound test every 10 years, right? Smart governance is a big thing now, and Maharashtra is definitely one, but a lot of these initiatives we see coming out of government of Bihar. Government of Bihar was the first government which did the entire railway line, 400 kilometers railway line surveys using a fleet of drones. So something that would otherwise take 6 to 8 months was done in like 6 weeks, 8 weeks, something like that. All right. So that's the kind of picture the drones will create, and where to build tunnels, where to build tracks, where to build bridges, etc. So this is real. This is done. This is not going to happen. This has happened. Okay. And LEED certification. So all this adds up to Industry 4 and smart manufacturing, because see, most of the technology we build ends up in one of two places. It either ends up in a finance business or it ends up in a manufacturing business, right? That's where 70% of all technology ends up. And when manufacturing takes an interest in something new, then it tends to become more mainstream. Think of 3D printing, think of AR, VR, which used to be very hobby-like things, are now mainstream manufacturing technologies. This is where my company does most of its work, all right? All right. Okay. Then coming back to IoT for a moment from Industry 4, there is not just one type of IoT. IoT is now, see, it's like asking what can you use internet for? There's no end to things. So if you ask what can you use IoT for, there's no one answer. But there are major verticals emerging. Consumer IoT is consumer products, smart wristbands, smart refrigerators. Nowadays you have this smart lock on doors also. So sometimes very high luxury apartments now, they are offering, you can control your door with a mobile phone. Personally, I don't think that's a great idea, because at the level, see, there's a notion of saying in IT security terms, there's something we call attack surfaces. हम जितनी ज़्यादा technology use करते हैं, that much more of a surface we expose for other people to intrude, right? So we are fine doing our lights and TVs and dim lighting and music system on a mobile phone, we are fine. I don't think most Indians would be fine with their main grill lock controlled by a thing. See, we are somebody on bank ka pen bhi chain se band ke rakhte hain, right? So it'll be a few years before we get comfortable with very core safety things controlled by computers. But consumer IoT. Then there's healthcare IoT, which is extremely doing well, really on its way. In fact, there are a lot of projects coming out of government as well as private players. If you as PG students or research scholars or faculty members, you want to do those, there are lots of those projects to be done. Healthcare IoT. On 13th December, there's a Pune Expo, Pune Manufacturing, Pune Defense Expo, side by side chalte hain dono. 13, 14, 15, Friday, Saturday, Sunday, annual event hai. You come there and see, there's lots of good stuff for you to come and take back. So we are also there, we are going to talk about smart manufacturing, but you'll get to see healthcare and a lot of good stuff there, all right? Commercial IoT, which is retail IoT, smart carts, you know, or what Amazon is doing. I want to automate my warehouse processes. That's all commercial IoT. And finally, industrial IoT, which is smart manufacturing. Sab mila ke 50% of it ends up being smart manufacturing. Okay? So this is what, and there are more. There's vehicle IoT. Now you talk about there's a whole new protocol coming up called CAN bus, which will be used for e-vehicles and smart vehicles and everything, right? There is, as I said, OBD, onboard diagnostics protocols coming up. See, everything ultimately will have a protocol. What a protocol means is all the major players will come and agree that this is the best way to build or use certain things. When we say Bluetooth, it's not coming out of just one inventor somewhere. Somebody proposed a model, then 3 or 4 more people who wanted to use it started using it. Till that time, none of us knew this exists. Over time, it became mature. People said, okay, now all of us agree. Now let's publish it. It became an IEEE standard, and now everybody uses Bluetooth. Now, I as an individual, I as a company have a better version of Bluetooth to build. It may be better, but it won't be accepted because Bluetooth is already there. If I want to build a new way to build websites, I say HTML purana ho gaya, naya banao. Nobody is going to accept it, even if it's better. The good part about IoT is it is still Wild West. The protocols are still being built. Not all of them are new, some of them are fairly well accepted. Many good protocols we have inherited from the IT world. But there is still a lot of scope for doing novel things, for coming up with new protocols, for coming up with unthought of things. A lot of greenfield stuff happening in IoT still. All right. And with 5G now, 5G is already here. We are using 5G. 6G आएगा तो ये और scope बढ़ता रहेगा ये सब करने में, right? So if you are in communications technology, so microcontroller definitely is there. VLSI manufacturing and VLSI design is likely to go really big. Secondly, communication technologies, because see, IT में हो गया, right? What can you do? You can optimize things more, you can build more AI, you can build more secure systems. Communication is still a challenge because we have good communication technologies for 30 feet range, Bluetooth. We have good communication for 250 feet, Wi-Fi. Okay? After 250 feet, things get a bit iffy. Now you have 1 kilometer range, which is raw radio. It's not as standardized. You have 20 kilometer range communication in the form of LoRa WAN, long range WANs. Very expensive, not scalable, not proprietary. It is scalable, but it is expensive. All right. Uske aage you want to do GSMs, hundreds of kilometers. फिर भी नहीं होगा. You are in a dam area, forest area, desert area. You have to use satellites, and now we have ISRO, NASA, ESA have come up with IoT channels for satellite communication. So very soon Vodafone will introduce IoT SIM cards, which you can't use for voice. You can only use for data and IoT devices, right? So there's a lot of work for communication to be done, right? So to give you an idea, I'm trying to figure out a 10 kilometer or a 5 kilometer range, radius range communication for a customer, but I have to hack together GSM, NRF, etc., etc. There is no one thing like Wi-Fi or Bluetooth that solves it for me. So something that works in a 5 kilometer radius, huge market. Okay? So different IoT markets are emerging, but see, at the base of it, the principles are largely going to be the same. Architecture largely same. Okay? So let me present to you the most vanilla version of architecture. Architecture is very important. Before you build something, you have to go and design it. Now, how much you want to design, up to you, right? Agar hum birdhouse bana rahe hain, you will just write some little bit outside with a pencil on a piece of plywood. That's fine. If you're building a 30-story skyscraper, you'll do far more design. But some design you have to do, right? Most mistakes that at least the student community I've seen making is they don't give enough time to design. So in the IT world, we were said 50% time you should give to design, right? 30% to build and 20% to test. अगर आप डिज़ाइन जितना कम करते जाओगे, उतना बिल्ड में नहीं जाता, उतना टेस्ट में आपका टाइम बढ़ता है, because you leave far more problems and they'll come out in testing, you'll keep fixing those. So 50, 30, 20 is what you used to follow. You have to spend time in design. So this is the most vanilla version of design that we follow, and we built this 6 years ago. At that time, not many protocols were built. Everybody was going with their own thing. But today, when people have come up with well-established designs, we are very pleased to share that it looks very much like what we came up with 6 years ago. So if 6 years ago हमने submit किया होता IEEE को, probably our name would have been on this. All right. So there are 4 tiers. This is most standard IoT architecture, right? 4 tiers. Read from left to right. The leftmost tier is the edge tier. Now I have put chips here, but if it was a business audience, I wouldn't show them microchips. I would show them CNC machine, robot machine, camera, whatever. Thing, remember? So this is where all your microcontroller technology, sensor technology, all the good stuff here, this is where this is deployed. Everywhere where you have to interact with the real world. As I said, the door opens, I want to put a sensor there, that's going to be in the edge tier. Because it is the edge. There is nothing, no technology ahead of the edge. Okay? So whatever you think interacts with the real world gets to be put here. Okay? Now, edge will either be connected to sensors or it will be connected to actuators. That's a relay, just switches things on and off, right? Or it could have its own network. Now there's a notion in IoT called mesh network, which means it's not just one device, it's 50 devices, 100 devices, 1000 devices, small devices of exactly the same type. Farm, assume a farm, you want to, over a 10-acre farm, you want to monitor soil moisture, right, every 50 feet, correct? So your 50 feet by 50 feet grid, cells in every intersection of latitude, longitude, you put a sensor, that's a mesh, correct? So this is also edge, because all those things are not talking to a server or a cloud anywhere. They are keeping that data where they are, edge pe, theek hai? Now this edge needs to convey whatever it has learnt somewhere else, to your mobile or to the internet or to a server somewhere. For the sake of simplicity, I am going to call this server as a cloud, because 9 times out of 10 it's going to be a cloud. But take that with a pinch of salt. It could be a laptop in somebody's basement, okay, or it could be a very small computer. So for example, if I only wanted to do IoT in this much room or this floor, I don't need a cloud, I don't need a server, I don't need a laptop. I can have, this is called an SBC, single board computer. This is a full-fledged Linux server, it's called a Raspberry Pi. Just about the simplest single board server there is, right? But it can do everything that a Linux server can do, a little slowly maybe. It has its own database, it has its own security, it has its own HTML, it has everything you need. It is wirelessly connected. So this could be a cloud within these 4 walls, right? If I want to cover the whole college, I can go to a server room and say, okay, this is my cloud. But if I want to say, I want to cover Pune, I want to cover Amravati, I want to cover Gurgaon, how do you have one server room? It becomes more complicated. So you say, okay, I'm going to put something on a cloud and everybody accesses the same cloud, right? So when I say cloud, take that word with a pinch of salt. It could be any one of these computing infrastructures. Okay so far? All right. So your edge tier has learnt, sorry ma'am?
We have to finish the lecture in some time.
Yeah, sure. इसके बाद case study है ma'am, so we can finish after this slide. Okay. Right? It's 2:42:14. 5 minutes we'll finish this slide. All right. So your edge is learning something about the real world. So it needs to tell something to the cloud. Ki temperature is this much, what should I do? Or a car needs to say, okay, I have spotted a cyclist on the road, right? So this data has to leave the edge and go somewhere else. For that, the next tier is a gateway tier. So many times when you talk to designers of IoT, they will not say communication, they will not say Wi-Fi. They will say gateway kya use karenge. Gateway means how does the data leave the edge and go somewhere else, right? So when you come to the expo, there will be some companies selling only gateways. They don't do anything else, they only make gateways, right? So gateway could be, in the simplest of case, it could be, where's the thing? It could be a router in your home. If you don't have a good broadband, it could be a SIM card. It could be a 2G network if you don't even have 4G. It could be a satellite, it could be LoRaWAN. I don't consider Bluetooth to be gateway because Bluetooth only gets you up to 30 feet. Okay? But if your Raspberry Pi is the server, then yeah, why not? Bluetooth becomes gateway. Okay? The gateway makes sure that your edge can talk to the cloud. All right? And not only your edge can talk to the cloud, your cloud can talk back to the edge. Because sometimes the cloud need to issue a command that stop or start the AC, or there's a fire, so call the fire brigade, whatever, right? So this is a two-way channel, gateway. And most of your processing, whatever computing you need to do, you should try and do it on the cloud tier, right? Because the more computing you put on the hardware, 2 problems happens. Every hardware requires that code or that intelligence, so it becomes more expensive. Secondly, when you want to change something, अगर मेरी एक device पुणे में है and second device is Amravati, I have to go to these 2 places and upload, right? There are workarounds around this, but not very good workarounds. If you put it on a cloud, I can wake up at 2 o'clock my time, log into my cloud and change that one setting. So the more stuff you put on a cloud, the easier it becomes to maintain, the easier it becomes to change, the easier it is to scale to a wider number of users. All right? And the last bit is, how does a user interact with your system? It could be a laptop, it could be a mobile phone, it could just be an LED somewhere. That's also user interaction. When you talk IoT, user doesn't interact with the system a lot. The system interacts within itself with other devices. User might come and look at the dashboard, push a button here and there, but it's not, you can build IoT even without the user interfaces, just the devices working with each other. So this is called, there's a very good name to it, distributed federated architecture. All right, I want to take 1 minute to explain this. It's not just IoT. You use WhatsApp. WhatsApp uses distributed federated architecture, right? Outlook uses distributed federated architecture. Why? What does distributed mean? That your technology is distributed between multiple different servers, different geographies, different hardware. Now it's very different. There's a reason I call these are 4 tiers. All right? Tier is different from a layer. You have a laptop. Laptop has a motherboard as the base layer, right? On top of that, you have the microprocessor, right? Intel or AMD. On top of that, you have firmware or bootloaders. On top of that, you have OS. On top of OS, you have drivers. On top of drivers, you have got your MS Word working, right? 6 to 8 layers. These are layers because they are all running on the same hardware. All these things are running on different hardware, possibly different geographies, possibly different technology stacks, right? Your sensor is just a microcontroller, it's just C program. Your gateway is running some variant of tiny Linux or something. Your cloud is Ubuntu. Then your phone could be Apple phone. So it's different hardware, different geographies, different networks, different technology stacks, different levels of computing power. It's very highly distributed network, right? So it's distributed, correct? The word federated has a very important meaning, right? Social studies, maybe studied federated governments. What does it mean? Federal governments, state government, central government. There's some responsibilities which state will do, some that will center will do. India, is it a federal government? It's not. It's a pseudo-federal government because for a lot of things, the central government can override the state government. State governments don't have their own, states don't have their own Supreme Courts. US is a completely federal government. There are things that states can decide that federal government cannot intervene in. Every state has their Supreme Courts. Federal Supreme Courts are only looking at constitutional matters, not state matters. Right, sir? Is that true? So, that's more towards an ideal federal government than Indian government. But what it means is center issues decisions, which we call as policy. Center का काम policy है, state का काम policy implement करना है. If I say Aadhaar card issue करना है, Aadhaar happens to be a central subject, but if Aadhaar was a state subject, central government will say these are the 10 rules that Aadhaar must satisfy, and every state is free to do according to its own thing. So policy at center, execution of the policy at the edge. So if cloud issues the command, so Alexa will say tube light chalu karo. But Alexa doesn't control how the tube light should work. Alexa doesn't care whether it's a single tube light or a matrix tube light. Is it a DC or an AC? Is it a 240 volts or a 120 volt? Right? Is it a halogen lamp or something else? It's for the IoT device sitting on the tube light to decide mera relay AC chahiye, DC chahiye, kitna heat hona chahiye, etc., etc. So how do you execute the decision? Decision is switch on the light. That is what the center, the cloud will do. How do you switch on the light? What kind of power you have? What kind of microcontroller you use? Entirely up to the edge. All right. So distributed federated architecture. It is distributed heavily. Every edge device chooses how to execute a decision, but it must execute the decision that the cloud has told it to execute. Federated logic. And most systems today are built in a federated architecture. Just try and remember this much. Distributed federated architecture. That's going to remain around for many more years. So this is how we build it. Okay. So ma'am is going to come back, I think. Okay. While ma'am comes back, I've got to a point where we are going to look at the case studies now. Any questions so far? Anything at all based on the last 1 hour, I think, right? Kitne baje? Sawa do? Yeah, so we started about 1 hour ago. Anything at all?
Only WhatsApp becomes federated.
Great question. There was another? There was one more voice? Yeah.
Basically you have mentioned about the traffic lights being communicating with each other. So is it existing in any of the Indian cities, or if not, why is, like, what
Okay, hold that. I'll first come to sir, then I'll come to you. Great questions both. All right, so sir said, how is WhatsApp a federated distributed system? See, because WhatsApp that you use, it's not the whole solution. You are using what we call as a WhatsApp phone client. There is something called client server. Client makes a request, server fulfills the request. When I say send this message, server will send the message, right? So we are exposed to one app inside the whole WhatsApp solution, right? Nowadays we also use a second app which is our browser, जो हम Chrome में या Internet Explorer में use करते हैं. Now this is where the distributed things come up. The program which is running on the Android is very different from the program which is running on an Apple phone, which is very different from the program running on the Chrome browser, right? Maybe it's been written in entirely different languages. Now these are the three things that we see. Now there are also certain things that we don't see. How do you know that somebody else has seen your message? आप मैसेज भेजते हो, आपको पहले कुछ आता नहीं है, right? The moment you get one tick, what does that mean? It means that your message has left your phone and reached the server. If you switch off your hotspot, you will not get that gray tick. So there is a fourth system in between which is collecting your message and telling you, boss, I have received it. You can show a gray tick to the user. Then once the receiver inbox receives it, you see a second gray tick. So the server is telling you कि मैंने दे दिया है पर उन्होंने देखा नहीं है, right? When the person sees it, you see two blue ticks. So there is some this rules based execution is called orchestration. So there is an orchestration server somewhere inside WhatsApp. Let's call it the fourth entity. We like to call these entities. So one is Android, one is Apple, one is Chrome, and the fourth is this orchestration entity. Then there is a warehouse entity also, because when we see reports ना कि किसी के phone से पिछले 6 महीने की history निकाली, वो कहाँ से आ रही है? When you delete your history or when you go to a new phone, you lose the history, but WhatsApp server doesn't lose your history. Fifth system. ऐसा कर करके there will be at least 8 to 10 systems inside WhatsApp. The server tells कि grey tick दिखाओ, but it doesn't tell your phone कि किस font में दिखाना है, कौन से size का tick दिखाओ. Your phone decides that. If you choose on your phone that I want to go to dark theme, the way that tick comes to you will be different. So the server doesn't dictate how your phone should show, the code of the phone decides how it should show that tick mark. So that's how it becomes distributed, because of many geographies and different technologies, and federated because you are just getting a JSON message from the server, message ID so and so, पहुंच गया. What to do with that message? In your phone you can also have a setting that I want privacy. I don't want anybody to see my ticks. Correct? So server doesn't enforce that. You choose it on your platform. Federated logic. Many more examples, but just a few things. About your question, traffic lights. So see, it's being rolled out. Bangalore definitely is doing this. I wouldn't be surprised if Amravati is doing, because everything they're building as a smart city. Pune mein, to be honest, I don't know whether they're doing smart lights, but once only in the last 5 years, once I was not wearing a helmet, so before I left the street light, I got an SMS कि आपको 200 रुपया fine लग गया. Right there, because there was a camera there. All right. I've tried it again, and I am so much of an enthusiast that I tried it again next week. कि फिर से बिना helmet के जाके देखते हैं कि system चल रहा है कि नहीं. Okay, so people in my family are a bit annoyed with these things, but and it was not working the next week. But that means some pilots are taking place. All right. Even now, when there's police presence there, police doesn't always stop you now. They scan. If you break a signal, they'll just scan it. They'll not run after you, and then you'll get a challan at the end of it. So some things are happening. Bangalore definitely doing far more. Mumbai, since a lot of Mumbai is built newly after independence or just before independence, they might be doing good things. Pune, they tried to do a few things, but I think they have stopped now. Don't know why. Right? How hard is it? It's not very hard. The problem is scale. How do you scale the solution? See, when you build a solution for 20 users, it's very easy. When you build it for 20 million users, it's a very different story. Everything changes. So YouTube used to build, the whole stack was something called Ruby on Rails. The technology, the programming language was Ruby, the server was Rails. Okay, 4 years ago, YouTube moved to Python and Django. Why? Because YouTube has, anybody knows how many concurrent users are there on YouTube? Mine is simultaneously logged in users. At the same second, what's its load, peak load? Guesses? 500 million. Half a billion concurrent users. And Ruby on Rails couldn't do that. So they moved to Python. So when we talk about rolling out a solution at scale, the whole thing is a very big, very different challenges. So that one thing that stops us is scale. But that's no reason for us to do pilots. So we can do pilot at Chandni Chowk, we can do pilot at Aund, all the big hotspots, we should be doing pilots. And we should do pilots with multiple different providers. कि तुम चांदनी चौक पे करो, तुम आउंध में करो, तुम यूनिवर्सिटी में करो, and whatever works best, best of breed. We should harvest the best of breed and execute it not just as a city, at a state level solution. So yeah, nothing big stopping us except for scale. पैसा है, technology भी है, पैसा भी है, करने वाले लोग भी हैं. Scale is a challenge. All right? Yeah.
You mentioned about the smart farming.
Yes.
What exactly it means? I'm not getting exactly what means.
I'll tell you. But now ma'am is also back. So what we'll do is we will end the lecture session, right? And let me answer your question as part of the case study session.